and building a 3D steel printer. What was I going to say next? All right. Hi, I'm Rory, and I'm building a 3D steel printer. And unfortunately, right now, I had planned a huge demo with, I was trying to make a, I wish I was holding, instead of this piece that was supposed to be attached to this, I was hoping to have a fully 3D printed, Hackaday logo or a chain. I don't know, but unfortunately, like all tech demos, nothing ever works, and everything goes to hell. But it's okay, because I guess this is supposed to be a proposal or something, so I'll just sort of stick with that. This is a proposal of my project, I guess. Right, I'm making a 3D metal printer. So, if we look at 3D plastic printing, that used to be really expensive. 3D plastic printers used to cost hundreds of thousands of dollars, who knows how much, crazy. They were very precise, they were good at what they did, but they were very expensive. And in the recent years, some patents have expired, and people have started to make cheaper kits, cheaper fully built systems you can go and buy. And because you're only working with a couple $100s of parts, they're not as good as quality as the crazy expensive ones, but still they're great value for money, and there's a lot of use cases where that totally makes sense. And I plan right now to make the same process sort of unfold with 3D metal printing, because right now those printers cost about $1 million each, at least, or multiple hundreds of thousands, like eight or 900,000, $1 million, I don't know, something like that. And they're great. They make they're used, by the way, in aircraft parts and hip implants, among other things. And they do have a niche right now. They do exist. They're very expensive, but the same revolution that happened with plastic printing hasn't happened yet, and that's what I'm trying to make happen with this project. That's a starting point. So the current existing 3D metal printers basically work by laying down you can imagine a little bulldozer driving and laying down a new layer of dirt somewhere. It's got a pile, it's pushing a pile of dirt and slowly laying it down in front of itself. And that's, so 3D metal printers would put down a little layer of metal powder, and then a laser or an electron beam comes along and melts some of that powder together, not all of it. And then the build platform moves down a bit, and the bulldozer drives over again and lays down another layer of metal powder on top of it, and then you melt that layer, and the process repeats. So, for instance, if you wanted to 3D print a metal cube, you could 3D. You draw your layer would look like a square because it's a cross section. You make a square, you move it down, another square gets put on top of it, and the process keeps going. And at the end of the day, there's a cylinder filled with metal powder. Because unlike the I think it's FDM, not too sure, the 3D plastic printer like a MakerBot, there's material left over. It's sort of a cylinder, fully filled, no matter what, it's always going to be fully filled with metal powder, except some of that happens to be stuck together. And then, so at the end of the day, your part's sitting there in that cylinder, and you open the door, a bunch of extra metal powder falls out, hopefully you can reuse it or something, and your part's just sitting there. So that's the process. And if I've confused you, which I quite possibly have, you can just look up selective laser sintering on Wikipedia or electron beam melting. And then those are the two names of the different processes, but you can sort of get a general idea of it. There's some cool YouTube videos of the companies who make it showing off their machines. Expensive, but great. In any case, what I've decided to do differently is a different way of melting the metal powder together. And people have been welding things for not hundreds of years. Welding has been around for about 100 years or so, and it's great. It's used to put together cars, motorcycles, like boats, everything. Super simple. It doesn't require having no air like the electron beam melting does, and it also doesn't have the potential to completely blind you. It will blind you somewhat, I guess, with the arc, but it's not as super dangerous as lasers. Also, lasers can be very expensive, and I don't have training in figuring, or I have no idea how to estimate the relative potential cost over as you manufacture hundreds of thousands of things. I'm not able to predict where exactly the new breed of sort of cheaper 3D metal printing laser machines are going to cost. But I feel that with 3D metal printing, if you do it my way with welding, I believe the cost should be a little bit less. But yeah, that remains to be seen. Hopefully it'll be cheaper. In any case, this is what I've got so far. On the right here is the custom-built TIG welder I've made. Basic things to note is it's a pulse TIG welder. It operates in pulses. There's no need to run continuous. It just melts a single pixel of metal at a time, if you could think of it like that. And yeah, everything's custom made. Well, depending on what you mean custom. I didn't exactly dig up the tantalum or whatever for the capacitors, but in any case, this is the build chamber. On top, we've got an XY table, which moves the electrode around to the proper coordinates to fire and melt the metal. And the metal melting happens here at the build chamber. This is basically, a piece of wood. We've got that cylinder I was talking about before in it, and there's a piston there. That's all there. One notable thing is that, unlike the other kind of 3D metal printers, you have to connect the piston to ground. Well, not ground, positive, but whatever. Yeah, so that's that system, controlled by an Arduino. And of course, this being a connected device competition, I've connected everything to a laptop, I guess. In any case, the idea with this whole system is that, theoretically, everything could be integrated. Maybe a BeagleBone would take care of all three of these things, but since I haven't figured out how to do the IOs on my BeagleBone yet, I'm going to use these things together. The idea is the laptop, eventually you'll feed the laptop with a STL file or something out of SolidWorks, your favorite 3D making things program. Laptop will tell the XY table where to move. It'll slice it up into sections first, tell the XY table where to move, and then it'll tell this thing to zap it. So yeah, overall, that is the entire project. Currently, the current status of the system right now is that the welder, I spent the most time on this welding box. I haven't fired it at metal powder, but this is about the fourth iteration of it. The first ones didn't really work at all, and this one does. It's sort of knocking holes in pieces of steel I have lying around. And right now I figured, great, it's time to pause on this for a second. Well, okay, I'm going to finish up a couple more things with it, but it's really time to focus on integrating everything together. So I've got this XY table, set up the electrode and all that. So over the next coming weeks, I hope to start printing out layers of things with metal powder and calibrating the various variables involved, like how far are pixels, if you think of them like that, spaced apart, and how much energy in terms of joules, or how much time do you spend melting each one. If you do too little, your metal melted blobs won't melt together. If you do too much, it'll cause a great sort of explosion and send the metal powder flying. There's so many parameters and variables to tweak. This could take months, if not years, who knows. Different densities of metal, I keep saying metal powder, but I'm using something that's more akin to the size of sand. Various densities, sizes, and shapes of that. All of these things need to be tweaked and tweaked again and sort of iterated on until the thing starts to, Anyways, I anticipate a long time spent tweaking the sort of metallurgy of the situation here, and also the control algorithms. But yeah, that's the state of the project, and I'll be posting more updates later, I guess.